Well, hey guys, how's it going? Thank you all so much for tuning in to today's video. I do have to apologize. I know I haven't had the chance to put out as much content as I would have liked since the last video that I put out, but things have been pretty busy for me. So just a little bit of a programming note. I am going to be moving here in about a week or so it's going to be kind of hectic for me once again. But by the time I get situated, I should be able to provide daily, if not every other day, content. I may do some live streams as well, but we'll kind of play that by ear. This is going to be a different video, and I think I'm going to go with this going forward. There is a lot of weather YouTubers out there at this point than there was 4 or 5 years ago, and a lot of them already do pretty similar content to what I was doing. And it's also not really my style. So what I mean by that is, you know, going through like the general forecast and maybe going over a couple of different maps. Instead, I am very technical minded, and I like to break down sort of what the setup looks like, what the ingredients-based forecasting looks like for a particular event. So I'm going to start doing that. Now, I'm going to try to keep these videos not terribly long, but at least somewhat of an amicable time to go over as much detail as possible and really give you a breakdown of the forecast. The way this will work is I'm going to give you sort of the insight from the mind of a meteorologist, right? What is it like going through these outlooks? What products are we looking at? What things do we focus on a little more than others? And sort of give you some insight there. So this is a real-time forecast. I want to put a disclaimer, 2 of them. Number 1, I have not looked at this forecast in full detail. I'm going to do this here kind of in real time. Sort of an impromptu, if you will. And also, this video is coming out the morning of May the 8th of 2024. So this is not applicable to, say, if you're watching this in the afternoon or evening. Of course, this forecast is subject to change, so you want to make sure you check your local NWS office, your local forecast, and the Storm Prediction Center for the latest information, again, depending on when you're watching this video. As of this morning, we currently have a moderate risk for severe weather for a lot of the Mississippi Valley region, really for portions of southern Illinois, getting back towards just south of the St. Louis metro, and then back towards Tennessee and Kentucky. Now, this is going to be, I believe, our second moderate. The last one we had was actually back towards Oklahoma, where we had those tornadoes, that nocturnal event that took place near Sulphur. And of course, our thoughts and prayers are with those folks even today. But this event is going to be slightly different. We do have the threat for tornadoes, but you're going to see here in a second that there also is a larger categorical threat for things like destructive winds and large hail. But let's start first with the tornado threat. We do have a 10% hatched for the same area, relatively in the moderate, a little bit broader, I should say. Again, central Missouri getting all the way back towards west central Kentucky, as well as north central Tennessee. So we do have a 10 sig. That means that we have a 10% chance of seeing not just tornadoes, but significant tornadoes. And remember, significant tornadoes meaning anything about EF2 or greater within that hatched area. I did kind of preclude before, though, that the other threats are going to be hail and wind. We actually have a 45 sig hail threat for Missouri, Illinois, and again, the same areas that were covered under that moderate are also under the threat for a 45 sig hail. I also want to focus too our attention to those that maybe are not in the higher probability forecast. We do have a moderate 30% for hail, even outside of that, extending all the way down into Arkansas, and then extreme northeastern Texas, even getting back towards northern Louisiana, and then that extends eastward as far east as, once again, central Kentucky and central Tennessee. We also have the slight risk for hail back towards the Carolinas, and I know for folks in Rock Hill, we saw a pretty significant hail event out towards the Charlotte area, so I don't think this is something that you guys want to hear, but it is, unfortunately, something that we do have to look out for. And then finally, we do have also an elevated chance of wind, 45% hatched for the same area in that moderate. I won't repeat the states. I've already done it like 3 times already, but you get the point. It's within this sort of tri-state region, Illinois, Missouri, and Kentucky, and then getting back down towards the lower to mid-Mississippi Valley region. And that extends even as far south as Dallas. So folks in the Dallas Metroplex will also be on the lookout for hail today. My guess is there's a dry line component to this. We'll find out if that's the case. So hold me to it, but we'll see. But there certainly is a reason why we're seeing some hatched significant hail probs, as well as hatched significant wind probs. Now, to explain this a little bit further, the 45 sig wind is saying essentially not just damaging winds, but ones that could be destructive. We're talking anything at or greater than 70 to 80 miles per hour. Significant hail, we could be talking about tennis ball, maybe even baseball size hail, if not greater. And a lot of these areas that are in this hatched sort of outlook. All right, so if you know folks that are in the mid and southern Mississippi Valley, be sure to share this video, be sure to like it. That way this gets out to as many of those folks as possible. And you can do that on a lot of places. It doesn't have to just be on Twitter. It could be Facebook. It could also be, hell, texting them the link to this very YouTube video. Whatever you got to do to get the word out, that certainly will be helpful. So today's video is going to be focused on the day one. We do have a day two outlook, of course, for tomorrow, a next chance for severe weather. And that's going to be the same system that we're forecasting for today across the lower and mid Mississippi Valley. That's going to continue to move off towards the east and eventually is going to encompass a slight risk for the Carolinas. And then we do have an enhanced risk for severe weather for the Dallas Metroplex and points southward near east central Texas. So again, we're going to focus today here on the day one outlook. I'll probably do a video tomorrow in the morning about the day two, which will be our severe weather threat for Thursday. So let's dive deep into this forecast here. And again, I'm going to try to keep myself to a time limit so I don't go like 50, 60 minutes in this video because honestly, guys, this is what I do for a living, right? As I spit out of my mouth, I love meteorology, right? I went to school for it, got my degree in it, and this is my passion. So when you're passionate about something, many times you might want to keep talking about it for hours and hours and hours. Honestly, with these type of events that are moderate risk or are high-end categorical risk days that we're seeing on a day like today, guys, you ask any meteorologist, ask any forecasting enthusiast, they could talk hours and dissect this event in many different angles, but we're going to try to keep it to a limited time here. So one of the things that we like to do here, and one of the things that I like to approach with is what's called the forecast funnel. So what we do is we look at our upper and our mid-level jet flow, and then we sort of break that down into the mesos. So some of more of our surface-based observations. So we're going to start first here. This is Null School Earth, by the way. Shout out to those guys. Wonderful resource. We're going to start first with our upper level jet, and this is sort of that global purview. And so what we have at the moment is we have this jet coupling. That's what we call meteorology. And our upper level jet flow, this is where our polar jet is coupling with our subtropical. So subtropical is usually going to, come out of the Pacific, right? Or sometimes people will call it the Pacific jet. This is moving oriented from west to east. And then our polar jet is actually ejecting southward and essentially orienting itself moving from south and then eventually east-northeast. That's how we get our troughing features, essentially, is when you get this sort of circumpolar low to be displaced towards the south and then sort of dig down the form of a trough and then eject eastward, of course, with eastward extent. So why is this jet coupling feature important? It's important because when you think about the grand scheme of things, our jet flow is going to be strongest when we have a strong horizontal temperature gradient. So in other words, if we have polar air that is coupling or converging on sort of this warm tropical air, well then that horizontal temperature difference, or what we call the temperature gradient, is going to be maximized. And so subsequently what that's going to do is at the 250 millibar height, which is what we're looking at right now, at about say 10 to 12 kilometers high, you're talking about winds that are likely to exceed something to the lines of 90 to 100 plus knots. So that's very strong, right? So what that tells us is in the upper levels right now as we speak, we are seeing some really strong upper level flow and upper level forcing due to the coupling of this polar jet and your subtropical jet, right? So that's the first thing that I look for. I want to see what's happening at the synoptic scale. Again, synoptic scale meaning upper level flow, mid-level flow, etc. Okay, so that is clear as day. What that tells me is there is really strong winds aloft. And if we're forecasting for severe weather events pertaining to like strong damaging wind events, That's what I look for. I look to see, for one, do we have really strong winds aloft? If I take this down a little bit lower, right now we're looking at the 500 millibar height. This is what we typically refer to on TV as the jet stream. You might see a TV forecaster mention the jet stream and show you all the cool, pretty colors that you can see right here. That is exactly what we're looking at here. So whenever you hear me refer to 500 millibar, I'm going to try to make sure that I say jet stream level, because that's typically what we refer to. And this is roughly around 3 to 5 kilometers. And there's an exact height to it, but we're just, kind of giving you a general range or ballpark, if you will. But our winds are going to be weaker, or they're going to decrease as we get closer to the surface. And why is that? Is because we have to account for friction, because the closer you get to the surface, the frictional force is going to act to slow the wind. So our winds are still going to be strong, but they won't be as strong as we go higher up. And also we have to factor in, again, that horizontal temperature gradient. So if we look here at the jet stream level, you can clearly see what we would refer to as a shortwave trough. And our shortwave troughs are typically associated with low pressure, right? So if we were to plot our surface low, it's likely going to be downstream of where our shortwave trough is. So roughly speaking, it might be somewhere near like Iowa, just to the east of the Missouri River Valley. Downstream of this trough axis is where you have really strong winds, right? So our winds are going to round the base of the trough, and they're going to maximize as they round that base, right? So this end point, right? So this is sort of our convergence zone, right where I drew the arrow. And then past that trough axis, you see divergence, right? So this is showing not just strong winds aloft still, but it also is telling us, hey, there is nice upper level divergence right where I drew my box. So what I mean by that is this. If we have upper level divergence, that then promotes surface level convergence. So if we have then surface level convergence, that would in turn promote things like convective development. Now, that's not always the case, because remember, we also have to forecast for ingredient-based forecasting. What's our dew point? What's our CAPE? What's our shear look like? In other words, what's our kinematic and thermodynamic environment? We don't know that yet. We haven't looked. But again, synoptically speaking, this is really well organized and very well put together. So if you can remember this, right, where I drew my box is pretty much where we have the highest probs of severe weather, is where that exit region of our trough is, right, or the divergence side of our trough axis. And also, just to let you know too, I don't think I mentioned this in the video at all, but I do want to note that this is the same system that has produced severe weather over the last few days. So just like what we saw in Oklahoma a couple days back, and by the way, I also want to correct myself, we had a high risk literally a couple days back. So I may have said in the beginning of the video, the moderate risk, it's been a week. Technically, yes, but we also had a high risk a couple days back. Anyway, this is the same system that produced severe weather for folks in Oklahoma back towards the plains a couple days back, right? And right now, it's actually just occluding. It's the same system, but it's an occluding closed low. So if we drew this once again, this is a closed low system, and then we have this embedded trough axis right near our closed low, just spitting out new systems. So we have another surface low that's going to be developing somewhere within the Iowa area, if it hasn't already, and that's going to kind of move off towards the east and southeast. All right, so we'll see that on the models here in a moment and see if we're right on that. But the point is, as you guys can tell, really nice synoptic environment for today, and we've already sort of diagnosed where we may see some of the greatest surface level convergence. Now, the last thing I want to look at here on the synoptic portion of this discussion is the 850. This is what we refer to as our low-level jet, right? So if we're looking for things like moisture advection as well as low-level veering, these streamlines are very important. And by the way, one thing I forgot to mention here is that these are streamlines, and so they are pointing in the direction of flow. Okay, so this 850 millibar jet, this is about, say, a kilometer-ish off the ground, above ground level. And so, again, this is where we would look to see for things like moisture advection, thermal advection, things of that nature. Well, clearly, if we're thinking in the mindset of the Northern Hemisphere, we have an area of high pressure that is off the coast of Florida. How do I know that? Because we have clockwise flow, right? Remember, in the Northern Hemisphere, Clockwise rotation is going to typically orient itself with high pressure, and then low pressure is counterclockwise. So this high pressure is thereby responsible for steering this Gulf Stream moisture essentially up northward. So this is considered sort of this southerly but also southwesterly flow that's orienting itself towards the mid-Mississippi Valley. And hey, would you look at that? We already just looked at the mid to upper level jet, and we found that our best area of surface level convergence promotion was going to be somewhere in this box, right? Well, look where our moisture is oriented. It's right near that convergence area. So the moderate risk, I mean, just off our synoptic discussion, is pretty much in the same spot, right? Nothing's really changed on that front. But we also, of course, do have even severe weather moving north of the central Mississippi Valley, even as far north as the lower Great Lakes today. So there's going to be a widespread chance of severe weather for a lot of folks later on this afternoon into this evening, and it may even start in the early afternoon. So we'll take a look at that here in a moment. But anyway, let me know if you have any questions on anything we talk about during this discussion. Feel free to post those down in the comments below. Now, what we're going to do is we're going to take a look here at the latest mesoscale analysis. Again, just to preface, these are observational data, and this is going to be subject to change. The video is coming out as of this morning, and we will likely see additional changes later on today. So what we're going to start with first is we're going to take a look here at just the surface observations. Right now, at the time of this video, we have temperatures out near central Missouri near the high 60s and low 70s, and we're automatically seeing our initial severe weather initiation out towards central Missouri. Now, this has had a history as of this morning of producing some pretty significant hail, upwards of baseball size. So this storm has been providing a history of really destructive hail, and this storm is going to be one that we keep an eye on downstream. So we're looking at it now, but for folks in that moderate risk, that's going to be heading towards you later on this afternoon and evening. So if you know folks, again, in these areas, especially areas like Carbondale, Paducah, back towards Mayfield, even towards Little Rock and Memphis, you want to make sure that you get this video out to them and know that, that they're aware of what's to come later on this afternoon. As far as the environment is concerned right now, I mean, the dew points are rather low. Our boundary layer is a little bit elevated, right? But I do expect that to change as our winds turn southerly. You can already see that taking place here in Arkansas. You got winds out of the south, just like what we were talking about with our 850 low-level jet discussion. You can already see that on your surface level map. You have southerly flow out towards Arkansas and even back towards northern Mississippi. And that even extends to the west towards the Red River Valley. So that moisture advection can eventually make its way up towards central Missouri. If you're wondering where the cold front and the warm front is located, you really have your warm front oriented just to the north, right? See where you have your easterly surface winds. It's going to be somewhere within this area. So the storm's going to be moving off towards the south and east. But again, it's going to be going into a more veered environment later on today that would be more so conducive for tornadoes. Right now, it's not relatively messy storm mode. We'll talk about that here in a moment. But once this moves off towards the east, the threat of tornadoes, as well as our other severe probs like strong winds and hail, are going to increase throughout the day. So speaking of which, one of the things that I like to look at is the hodograph, and it's because I like to see what the storm is feeling, right? Because ultimately, storm behavior dictates all. You can have the best environment to produce severe weather, but if the storm's not feeling it, it ain't going to do it. So as of right now, really elongated hodos. It's kind of hard to see, and I do apologize, but if you can actually notice here on some of these hodographs, what this is actually telling us is they're wind vectors. So it's showing us here that we have low-level veering, but then we're pretty much linear on our upper-level wind vector. However, they're very elongated. So what that means is we have very strong wind shear to work with aloft. We already talked about that earlier on in our earlier discussion about the strong winds aloft. Well, our hodographs are also showing that too. So we have really strong winds aloft, but you notice that our veering for the most part is not that great relative to right-moving storms. So as this moves off towards the south and east, though, we are going to see these hodographs sort of veering a little bit more. So if we look here at the wrap later on today, watch what happens. We get those storms to cluster a bit become a little bit more quasi-linear, and then we get some sort of discrete supercell activity. But you also notice that the veering does slightly increase. But I will say that it's not incredibly cyclic shape, right? We're not going to be seeing, necessarily discrete supercells. These photographs would indicate and be indicative more of kind of a messier storm mode that would still rotate. So we could see maybe, embedded supercells. We could see more clustering going on, multicellular clusters, but all of which will still have the potential to produce tornadoes as well as hail and damaging winds. So the damaging winds we've already established pretty much comes from the strong kinematic environment aloft, but the other component we have to look at too is our CAPE. And so one of the things that's important for diagnosing strong wind events is looking at things like your mixed layer CAPE. And so as we go forward in time later on today, you see that we get our mixed layer CAPE to strongly increase. Notice how that moves towards the north with time. That's because, again, we're going to have that sort of diurnal heating increase throughout the day. As the sun rises, right, we get temperatures to warm. And then we're also going to have our moisture advection continue to lift northward with time as well. And so that's reflective even in our mixed layer CAPE profiles. And you can see here that we're seeing mixed layer CAPE upwards of anywhere between 3,000 to even 4,000 out towards northeastern Arkansas and then back towards west central Tennessee. That is very strong. So that, if that potential energy is tapped into, that mixing, that rapid mixing, is going to potentially produce some pretty strong downdrafts. And there also is a parameter for CAPE in the form of downdraft, also what we call DCAPE. So how much potential energy there would be for essentially downdrafts. And it even says here potential strength of rain-cooled downdrafts with deep convection. So we are expecting some pretty deep convection today based just on our CAPE profiles alone. So of course, as we go forward in time, look at your DCAPE profile. You have anywhere between 1,000 to 1,200. That is also very high, right? So what I'm expecting here today is these cells, and you're kind of seeing it right now here in central Missouri already, is we're going to get a lot of cell mergers. And what that will do is when you get all these cells that have their own little cold pools, they're going to merge together and create one big one, right? In possibly the form of an MCS, in mesoscale convective system. And so the bigger the cold pool, that means that you have sinking winds or winds that are rushing down to the surface. They hit the surface, then they're going to rush out in the form of an outflow boundary. And so those strong winds are going to be certainly in the cards today because of that. You get a lot of cell mergers, you get cold pools to merge, you increase your cold pooling, and then eventually you get one broader one, and that produces stronger winds later on in the day. So that's exactly what we're looking for folks, again, in places like Paducah, out towards southeastern Missouri, west central Kentucky, extreme west central Kentucky, and extreme western Tennessee out towards Memphis. So let's take one quick look here at some of the models. So we'll jump to that here. We already looked at the outlook, so let's give you a couple model guidance scenarios, and I think we'll pull a sounding too from this as well. So we'll look at the RFS just for, craps and giggles, as I would say. But there are a lot of models we can look at, but I'm only going to focus my attention here on a couple just for the sake of time. I do want to mention, though, one thing to take into account with a model like the Rapid Refresh. It does tend to have an inherent bias towards supercell development. So we got to be kind of careful about that. We don't want to go too overboard and kind of put all of our eggs in one basket with this setup. But, with this model, we have to keep in mind that it is going to possibly overdo some things. So as we go forward in time, it did pick up this cell really well. By the way, this is the 9Z run, so it's a little bit old. But it did pick up that cell quite well. It has it moving off towards the east, just the northwest of St. Louis. And then, as I mentioned, the RFS wants to fire supercells out towards Evansville, Indiana, later on today by 19Z, right around about 1, 2 o'clock. So we'll take a look at that here in a moment. And then also you have supercells firing out towards northeastern Oklahoma. Now, do I think we're going to see big mothership supercells like this? Probably not. Again, the RFS does tend to overdo this. However, this is the environment for discrete supercells initially. It's not going to be very long. As I said, the main event here is really going to be sort of a semi-discrete to sort of this cell merger, big line of storm mode. But there is the chance for a very, very short window we could see some discrete baby cells and even some supercells. So RFS does pick up on that. We'll look at another model sort of output here right now. I guess we'll look at the HER, the latest HER run here, 13Z. And so, again, I will mention that the HER does not, it does pick up this actually quite well. And then we do have additional convection that fires off towards Tennessee and Kentucky. That's not going to be until, again, about 12, 1 o'clock. And so as we go forward in time, you see these storms continuing to develop and then eventually get just a lot of clustering. Pretty much like what we talked about. And honestly, I think the HER has a lot better of a handle on this event than the Rapid Refresh does. Rapid Refresh, I think, is going way too bullish on the supercells. So the idea that we'll see a lot of this clustering going on later on in the afternoon and evening is certainly indicative to what I expect to happen. And remember, because we have this streamlined flow aloft, expect to see some training at a lot of these storms. So I know we didn't talk about it today, but there certainly does exist the chance for some flash flooding out in these same areas that are under a moderate risk for severe weather. So places like Kentucky, Tennessee, you guys need to be mindful, have an action plan, turn around, don't drown. If you see a flooded roadway, just turn around. Don't even try. I've seen way too many videos of people getting their cars stuck in a creek that they didn't know even existed in the parking lot, right? So you got to be very mindful and very careful about that. But the HER is certainly showing a lot of clustering taking place throughout the day today. And then eventually, by the time we get towards this evening, you notice this little Boeing structure here. Like we talked about, expect a lot of these cells to undergo some cell mergers and eventually form a line in what we call an MCS. This means if this were to come true, we would have really nice cold pooling, cold air behind it rushing forward in the form of straight line winds. So even if you're not in the moderate risk and you're more in that slight risk for folks in the Carolinas and eastern Tennessee, you want to be mindful of this scenario. This certainly is plausible, especially as we get towards the evening and the overnight hours. So, we're not worried necessarily about the Tor threat for you guys. There is a non-zero chance of that. But I think my biggest concern for folks in the area circled is going to be damaging straight line winds. And I hate to say that because, as I mentioned at the very beginning of the video, Charlotte has already seen a damaging straight line wind event from the microverse event a couple weeks ago. This is probably not the news you want to hear, but this certainly is a plausible scenario for later on in the day. So lastly, I want to take a quick little sounding here, and I'm going to take it at a couple of different spots, and we'll just kind of go off of the HER rendition. So we'll take a look here and see what we're looking at for Central Tennessee. Same sort of situation applies, right? So we've seen sort of this kind of messy HODOs, which would be indicative of more of this messier storm mode. We do still have this low-level veering that exists by our red and pink vectors. So that certainly is the case. Again, this is from Central Tennessee purview. Look at our PWAT, though, guys. This is going to be the theme of today. 1.64 inches of precipitable water. That is a lot of saturation to work with and a lot of precipitable water to work with. So again, flash flooding is certainly a significant threat today as well. Let's not forget about that. Also, CAPE profiles, 4,000 surface CAPE, also mixed layer near 3,000. So remember, CAPE is convective available potential energy. How much energy or potential energy the environment has to tap into. And then finally, our lapse rates. 8.2 Celsius per kilometer from surface to 3. So what that tells us is as we move and as we lift our parcel, or this arbitrary air parcel with height, we are cooling that air parcel at 8.2 degrees Celsius per 1 kilometer. So that is really steep. That's a very rapid cooling, rapid destabilization as we move with height. And also here is that good old CAPE profile looking nice and thick, right? So when we see a nice and thick CAPE profile, that's not good. That's a lot of energy to tap into that the environment has to work with, essentially. So let's take a look at one more sounding here. And then I do want to go over one last thing because I did forget about it. Can't you tell this is impromptu? So there is one last map that I want to look at. Otherwise, I would be sacrilegious of a meteorologist not to look at the map that I want to look at. More on that in a moment. The other thing I wanted to see here is just looking at, we'll go closer to that moderate. This would take us into the afternoon, right where that big chunky cell is initially. This looks really nice, right? This is our earlier initiation of our cells out towards western Kentucky. You can tell that we have this pretty darn veered environment, very cyclic shape. As you can kind of make that out here on our hodograph. And for the most part, our shear magnitude is pretty good too, 23 to 33 knots. We're talking about effective shear of 48 knots. And for the most part, we have some good storm relative inflow. So this is an okay tour environment, to be honest with you, and even the SigTor parameter picks up on that too. K profiles are also really good. Our LCLs are not as elevated, so we're talking mostly surface-based convection here to start, or slightly elevated. And our lapse rates are also very steep. Again, precipitable water in western Kentucky, 1.87. Did I mention flash flooding? Yeah, that's a big concern. When you see precipitable water that high, if we're talking close to 2 inches, that's pretty crazy. And by the way, I want to look at that real quick too. I think the WPC, do they have the WPC outlooks on here? Yeah, they do. And look at that, we're under a moderate for flash flooding for the same areas under the moderate for severe weather. So there you go, right? If you didn't believe me then, the Weather Prediction Center also is concurring with that same idea. All right, folks, so there was one last thing I wanted to look at here before we call today a day, and that's going to be the dew point wind barbs. I forgot to look at this because if you remember from earlier on in our discussion, I wanted to see if there was some sort of dry line being infected. There's some sort of dry line component. So I want to look at the dew points first, and then I lied. I'm going to look at one more map, and then I'll be done. So here is our dew points. By the way, this is our moisture. I mean, look how stout that is. We're talking about dew points in the mid to high 70s. This is very unseasonable for this time of year. This is something typically you would see, probably in July or August. So we're kind of running a little bit early on this type of humidity, but here we are, right? So there's our occluding low up towards the Dakotas. And then our system of concern, the surface low you can kind of make out here, is actually going to be positioned out towards, sort of this Kansas City area. So a little bit off on the low, but not too bad. It was a good try. But for the most part, again, here's our moisture advection. And yeah, there really isn't there's the dry line, but the dry line itself is actually going to be oriented more towards sort of this area, right? So our dry line's actually sloshing back towards Texas. That's why we actually have a 15 sig out there too for hail in the Dallas Metroplex, because your dry line is oriented just towards your west. That kind of makes sense, right? But then the other thing I want to look for then is, okay, well, if you don't have sort of a really stout dry line advection, what else can we look for that would give us an idea on what this dry air component will be for the hail to be supported? Well, we do have this southerly surface flow, but then we also have, you can kind of make it out, the southwesterly flow. So if we're getting southwesterly surface winds meeting up with this really deep moisture boundary layer, or deep moist boundary layer, that would be indicative of some pretty good ingredients for hail. We can also look at one more product, and that is our lapse rates in the mid-levels. And so if we take a look here, look at that. Really nice lapse rates earlier on today, but they do sort of decrease throughout the day. I wouldn't really get too hung up on this per se. It looks as more that this is just a deep moist boundary layer. We got deep convection because of our large cape profiles, and then couple that with some southwesterly surface winds out towards the west of the mid-Mississippi Valley. That's what's going to be conducive of hail, and it's going to be in that same area where we have our moderate risk for severe weather. So once again, to end things off, just as a reminder for folks, we do have a moderate risk for severe weather today, and that is going to be for the areas shaded in red. Again, southeastern Missouri, west central Kentucky, northwestern Tennessee, and even western Tennessee, and then back towards Paducah, Carbondale, Evansville, Indiana, Mayfield, Kentucky, as well as the St. Louis Metro and Memphis, Tennessee. So be sure to like and subscribe to the channel for more content. Be sure to also share this video with family and friends that will likely be impacted by today's severe weather. We will be back here tomorrow with our day 2 severe weather discussion, and that's going to be for the Carolinas all the way back towards Texas for another round of severe weather. Listen, thank you guys so much for tuning in, and we'll be back here with another video tomorrow. Take care.